Welcome, everyone. I'm Miriam. I'm your moderator for today. If you are attending online, please put in any question in the Whova app. And without further ado, here's Josh Mandel.
Awesome. Thank you, guys. I'm going to show you kind of a grab bag of topics, and I would love to get my screen share going. I don't know if there's an issue with the projector, but I can make sure I've got things on my side. Oh, perfect. I'm going to do a grab bag of topics related to the latest release of the Smart App Launch specification, and also give you a preview of some projects that are going on now that may eventually land in the Smart specification. And because this is kind of an intro that goes across topics, it's going to be a little bit of a grab bag. I'm going to cover maybe 5 or 6 different subtopics over the course of the next 35 minutes or so. If folks in the room have questions during the presentation, feel free to just raise your hand and ask, particularly for clarifications or any quick follow-ups. I'll call on you and I'll repeat the question so folks online can hear. And we'll save time at the end for broader Q&A and for an opportunity to answer some questions from folks online. Without further ado, let me jump in and say the Smart App Launch specification is currently published at hl7.org/smartapp-launch. And the current version is version 2.0. You can get a sense of how long we've been working on these specifications from the versions list, which is going to be even better if my internet works. So this one was published late last year, and the original Smart App Launch was the 1.0 spec, which was published all the way back in 2018. Just as a quick reminder, this one here, the original version 1 of Smart App Launch, that is what is currently regulated in the US. It's what every certified EHR needs to be able to support. If you're interested in building an app today that scales across the US ecosystem, you can focus on Smart V1, great place to start, core access to data. Like, you should think about that as really what's on the ground today. And you should think about Smart V2 as an augmented set of features for future development. But based on our early experience with Smart V1, we've identified several areas that we wanted to improve. And maybe the most common request was about scopes or access permissions. In other words, when a client application wants to get access to certain data from the EHR, it can say something like, I want access to this patient's observations. And in Smart V1, that was the granularity we had. It was the FHIR resource level of granularity. And for some resources like allergy intolerance, like, that's probably pretty good. Like, I either want to share my allergies or I don't. But for other resources like observations, it's a very awkward and broad thing to say. I mean, FHIR uses observations for all kinds of purposes, and maybe I'm comfortable sharing some and very uncomfortable sharing others. So this is a challenging area. Like, ultimately for patients, you might want to surface some more functional scopes. Things like, well, share my mental health data or don't. Share my data related to this particular diagnosis or don't. These are the kinds of data sets I'm comfortable sharing. And from a patient perspective, those are sort of meaningful, but they might be quite varied. And they might show up in all kinds of different places in the data server. If I'm going to share data about my mental health or not, that could mean redacting notes. It could mean hiding certain medications. It could mean hiding certain lab results that pertain to blood levels of those medications that are used to regulate the meds. The signature of a certain class of data could show up all over the record. And we didn't know how to build support for something like that at scale in a way that we thought would be workable in lots of different EHR and health technology systems. And so I do want to say that what we came up with in these scopes is for sure a compromise between the kind of granularity we thought was important and something that we thought would be implementable in the real world. So here's what we've done with smart scopes in V2. The first thing that we've done was to provide a cleaner mapping between our permissions or scopes and the FHIR interaction type. So in FHIR, we have these kind of CRUD APIs, create, read, update, delete, and search. And so we call those out explicitly now. If you're asking for a scope in Smart V2, you can say, I want full CRUDs access, or I just want to be able to read and search this resource. So you can say more specifically what sorts of interactions you want to do with it. And then you can also append to the scopes FHIR query parameters. FHIR search parameters that can further specify exactly what's going to be shared. And so for an example with observations, if we look through the scopes and launch context page of the spec, we could say something like, I want to share observations associated with the patient in context for the laboratory category. Now, this scope is a mouthful, and we can talk a little bit about techniques for reducing the verbosity, but this is sort of explaining in a way that maps pretty clearly to the FHIR API surface area what kinds of queries should be allowed. And so a scope like this is what we call a granular scope, and it appends what looks a lot like a FHIR search parameter to the end of the scope. Now, it doesn't mean that you're only able to make exactly this API call, but it means observations that match this category are ones that the app should be able to read and search, and observations that don't are observations that should be hidden from or not returned to an application if this is the only scope that the app has. So those are the two major changes we've made to the scope language in Smart. And we also recognize that these things will be living side by side with the versions of scopes we had in V1 and in V2. David, quick question.
Why did you get these in the Smart scopes rather than use FHIR consent?
Why put these in Smart scopes rather than use FHIR consent, for example? I mean, I think the short answer is we wanted to build this into an OAuth workflow where an individual was going to be responding to and determining a set of provisions. This could be modeled all kinds of ways: consent, permissions, nested terms in a tree. What we learned in Smart V1 was even a flat list of scopes was kind of a lot to work with. We didn't necessarily want to flip the model and require additional state be stored somewhere other than the authorization flow. So we kind of built on the model we had by fixing it for the most common requested features that we got. And like I said, this is very much trying to thread the needle of capabilities. I want to highlight in the conformance page, if you're building a server that supports Smart V2 scopes, you advertise that explicitly. So you could say, I support the permissions V1 scope syntax, and you can say, I support the permissions V2 scope syntax. And you can support them both side by side if you want to be able to support applications that use one or the other. And we define a mapping between them. So that's a very brief introduction to scopes. And I promised you a grab bag. So that was the first item in our grab bag of topics. I'm going to switch gears next and talk about client authentication. Another feature that we introduced in Smart V2 is asymmetric client authentication. And as a quick refresher, when a client app wants to talk to a server, it might be what we call a public client, which is to say it really can't authenticate. It doesn't have any secrets or any place to keep a secret that a nosy end user would not be able to pry it out from. And so those are what we call public clients, and they're perfectly allowed and supported, and they can be part of a trustworthy ecosystem as long as you account for the fact that they can't authenticate. Very common. Actually, the most common kind of app I build is a public client. But if you've got a client that can maintain a secret, we call that a confidential client in OAuth. Then there's the question of how do you authenticate? How do you manage that secret? And in Smart V1, we had kind of the most common OAuth paradigm, which is a shared secret, a symmetrically shared, basically a password, although it's called a secret, that the client can hold on to. And every time it wants to authenticate to the server in order to get a new access token, for example, it sends the shared secret to the server to say, hey, I know this password. And that's how the authentication works. And it's a very simple pattern. It works very nicely, but it also has a couple of drawbacks. One is, as a client, you need to establish a shared secret with every server you want to talk to. And particularly if you're registering your client with an EHR vendor that has hundreds of provider customers, maybe all around the US, you might need to manage hundreds of secrets just for that one vendor in order to be able to authenticate to each customer separately. That can be a challenging set of operations to manage. And then if you want to switch out your secrets, maybe your app has been compromised. Maybe you're just trying to follow best practices for rotating secrets so that you don't keep any one for too long, just in case. Managing that rotation can be very challenging. You have to go back to the portal from that vendor and do something and publish a new configuration of your app. So with asymmetric or public key authentication, some of these challenges go away. Rather than registering or sharing one secret, the app can register its public key, or can even register the URL of a set of public keys that the app controls. And that way, anytime the client needs to authenticate to the EHR, it can sign a one-time assertion with that private key and submit it to the EHR. And this allows the app to potentially use the same private keys for communicating with more than one EHR, because the EHR itself only knows the public key. So it's sort of safe from the sense that just because I authenticate to system A doesn't mean that system A can impersonate me when they talk to system B. They don't have my private key. So that's a real win. And the other one is allowing clients to maintain their own or control their own key rotation. So if I'm registering a key set, a website where I maintain my current keys, I can add keys to that key set over time when I want to introduce new keys. I can remove the keys that I've rotated out or keys that I've revoked for my client, and servers can stay up to date with that key set. So that's the basic model that's documented here on the asymmetric client authentication page. It's all based on JSON web tokens, JSON web signatures to be more specific. And we call out a couple of algorithms that servers need to support so that we have a common basis so clients know at least one of those algorithms is going to work. But we also have a discovery process. So servers can advertise the full set of signature algorithms that they support. It's always going to have these guys in it. And this is something we've worked on for years. It's actually part of the bulk data specification was this asymmetric client authentication capability. So we've got real world experience with this, working with major EHRs released in production. Just realized I'm still wearing my mask and I don't really need to be here. Ooh, very nice. So this is something that we actually have a fair amount of experience with. What we recently did was to move this particular page out of the bulk data spec and into the smart on FHIR spec so we can use it for all kinds of apps, not just backend services. So it's got a new home, it's a new page in this spec, but the content has been developed with a lot of community input, and it's very much aligned with what's happening in bulk and with the EHR certification requirements and same kinds of workflows that are happening in UDAP from David's presentation yesterday and so on. On the conformance page, just to sort of highlight how this works, again, a server can advertise in its metadata the fact that they support asymmetric client authentication. We call that the client confidential asymmetric capability that a server can include in its capabilities list. So clients can tell when they're connecting to a smart server just by looking at that configuration file, whether that capability is supported or not. Any quick questions on the asymmetric authentication topic before I move on to the next grab bag item? All right, let me check if people are like awake and paying attention and if this is making sense so far generally. Okay, raise your hand if I've lost you. Okay, I know. I know, it's cheating, but it makes me feel just a little bit better. Okay, let's see. Next item in the grab bag, PKCE. Proof key for code exchange. So with very wide implementation support for OAuth APIs kind of across the ecosystem, this is not a healthcare specific thing. We've learned some common failure modes or places where an OAuth workflow can go wrong. And I'm not going to go into a ton of detail on this, but I want to give you the kind of motivation for PKCE. So this is a reminder of what an OAuth flow looks like in general, which is to say, an individual user is, so the app is going to make an authorization request, which redirects to like an EHR. An individual user is going to click a button saying, yes, I want to approve this app. And then what's called an authorization code is returned to the app if the person said yes. With that authorization code, the app can request an access token. So that's a basic OAuth flow, works great. But what happens if, imagine the following scenario. You've got a mobile phone with an app on it that is registered for this redirect URI. So when the EHR sends you your authorization code, it lands back in your app. This is great because your app can continue with the workflow. Imagine there's another app on your phone that has maybe accidentally, maybe maliciously registered for the same redirect URI. At least historically, on some mobile platforms, the OS would say like, well, I'm going to send it to a random one. Any app that's registered for this redirect URI, I'm going to pick one. And sometimes I'll pick the right one. Sometimes I'll pick the wrong one. Well, what happens in that case is maybe the wrong app is going to get your authorization code. Now, we're talking about mobile applications. They're public clients because they can't really keep a secret, at least in the general case. And so if the wrong app gets the authorization code, the wrong app might be able to trade it in for an access token. That's one of the threats that really drove the development of some additional parameters in this OAuth flow to prevent that from happening. To say, even if the wrong app gets this authorization code, let's make sure it can't use it. Let's make sure that wrong app can't trade it in for an access token. So how does it work is during this initial authorization request, the initializing app creates some sort of a random number. It's going to hold on to it in memory for the next minute or so. And it sends a hash of that random number as a parameter in this request. The rest of this workflow goes as intended. And at this final step where the app needs to trade in their authorization code for the token, it's only allowed to make this call if it can also supply that random number, the pre-image to the hash. So it's a way of proving to the authorization server, like, hey, I'm the same app that started this request. And if the wrong app gets that authorization code, it won't know that random number. It won't be able to supply the right parameter. And if it tries to get an access token, it's going to get an error saying, sorry, you didn't have the right PKCE verifier parameter. So that's the intuition for how PKCE works. It's designed to prevent the wrong app from getting an authorization code. Let me make a couple of security notes that are sort of interesting, because we kind of did a little hand-wringing trying to decide whether this was really worth adding to the spec. And if we were going to add it, should we make it an option? Should we make it required, or what? In the end, we decided to add it, and we decided to make it required. But it wasn't an obvious choice, because really on the mobile platforms today, one app really shouldn't be able to get the same redirect URI as another app. It's just on mobile, it's not really a thing anymore. There's a very good practice in mobile apps of registering redirect URIs using HTTPS URLs. And so as an app on like iOS or Android, you can register for redirects with a domain you control. And you can prove to Apple or to Google that you control that domain. And then only your apps will be able to register for those redirect URLs. So they look like regular web URLs. You've got to own the domain, but redirects happen entirely on device, and they just open up your app directly. So like one of the main threat vectors here of, oh, I had a malicious app that was able to receive redirects for me, like it's not that much of a thing these days on mobile. So that particular threat, particularly on mobile, maybe not the biggest deal, but maybe there's some edge cases, maybe it's worth mitigating anyway. The other interesting design consideration is in the PKCE specification, or actually in some of the OAuth best practices that were developed later, they realized that even though this verifier thing was designed to solve this really narrow problem, it also had some additional benefits to prevent certain kinds of session fixation attacks. So maybe it's not the case that the wrong app is able to receive an authorization code, like maybe that's not what's going on, but some malicious actor is going to try to get you to open up the right app using a code that they've injected. So maybe they're going to send you some kind of link that injects an authorization code from their account, and they're going to send you this link and try to get you to complete the connection on their device. That's one example of what's often called a session fixation attack. And if you kind of work through the possibilities here, like some bad things can happen. If I can trick David into connecting his app to my account, for health data, when it's a read-only API, I guess that's only going to help David to read my data. But like imagine a banking API where he's going to be able to like deposit funds and he thinks he's depositing them into his account, but really he's putting them into mine. Bad things can happen. So using this PKCE verifier is a good way to prevent those kinds of things as well. So what we've said in the specification is that the EHR, if they're supporting Smart v2, they shall support this PKCE parameter, this code verifier, to make sure that authorization codes can only be used if the client knows the kind of pre-image of that hash. I won't go into all the implementation details, but I'll just say what it means is there's two additional parameters on the authorized request. There's something called a code challenge, which is that hashed value I mentioned earlier, and something called a code challenge method, which is one of these great standards tricks for saying, well, we've got one algorithm for doing this today, but maybe in the future we'll have different algorithms we want to use. So we'll pass along a value that says which algorithm. And in this case, it's we say there has to be support for what's called the SHA-256 hashing method. In the future, there could be more. And so we pass along the method we're using as a parameter. And these are all standardized parameters that are defined by the IETF specification called PKCE. That's RFC 7636. And unless folks are interested in learning more about this topic right now, I won't go into more detail, but let me see if there are any questions or clarifications I can give on this proof key for code exchange. David, yeah.
You've settled on hashing SHA-256.
You
look at SHA-3 or
Yeah, so Dave said, why SHA-256? Why not SHA-3 or anything else? I mean, the example is this is one of the methods. It's actually the only good method that's defined in the core PKCE spec. There's extensions that you could build, but this is going to be the most commonly supported one because it's part of the core PKCE spec. So that's why we used it. The only other method in the core spec is something called plain, which you don't want to use for various reasons, but it's there for kind of compatibility reasons. We prohibit that in Smart. All right. Next, third grab bag item. I'm only going to briefly mention this one because it's not really useful for app developers, but it's very useful if you're at a health system and you've got a certified EHR with its own FHIR server, and you're interested in maybe augmenting that ecosystem. Maybe you want to put more servers into place next to your EHRs FHIR server. Like maybe your EHR supports a core set of clinical data, but you've got an additional server that supports imaging data or genomics data or patient-reported outcomes that you've been collecting within your organization. All kinds of things that the main EHR might not store directly. And so token introspection is a building block that helps you do that. As a healthcare provider running a FHIR server or more than one FHIR server, it provides a way for the patient to make an authorization once to say, I want to share all kinds of data with this app, even though the data are living on 3 different servers. So what token introspection allows you to do is if you're building that imaging server, rather than minting your own access tokens and managing your own app registrations and so on, you can piggyback on the existing infrastructure. You can say, I'm going to treat as my source of truth the EHR's authorization server. So if the tokens are generated by that EHR's authorization server, they're good enough for me. And so token introspection is a way for an arbitrary resource server to look at the access token that has been passed into it, maybe by a client app that's saying, hey, do you have any imaging results for Josh? Here's my access token. So the imaging server can take that access token and say, well, I don't know what this means, but let me send it over to a token introspection endpoint from the EHR. Let me ask the EHR, is this token valid? Who is it valid for? What scopes should it grant? And that way, if you're building the imaging server, you can see, oh yeah, it's valid for Josh, or it's valid for patient 1, 2, 3. It's valid for imaging scopes. So I'm willing to proceed with this request. And it's a very, very simple API. So for a client calling this API, like my imaging server might call it, it posts to an introspection endpoint hosted by the EHR. It says, here's the token I've seen. I want to know what this token is all about. And the EHR responds with a message like this. These are standardized APIs from IETF, and we augment them with a couple of fields that are specific to SMART. So these are all kind of standardized parameters up to this point. So the EHR says, yes, it's an active token. Here's the client that it is a token for. Here are the scopes that this token grants. Here is the subject or the end user who was responsible for authorizing this token in the first place. So those are all kind of standard things that will help a server figure out what data to return on this request. And then we augment it with the FHIR context, things like what was the patient or the encounter in context, who was the FHIR user in context, or who the user who approved the app. And this expiration claim is also a standard claim, which is when is the token going to expire. So that's a very quick view into token introspection. And it's a capability that we added because we see more health systems trying to use their certified EHRs as one component of a broader ecosystem. So it becomes important to be able to support this sort of flexible infrastructure. Okay, those are all the new features in Smart V2 that I wanted to highlight. Let me tell you about a couple of things that are coming down the pike, projects that we're working on in the Argonaut community this year that I think might be an interesting addition to the Smart Spec in the future. Maybe these will get published as standalone work, maybe they'll be incorporated, but I like to think about the Argonaut group as kind of an incubator or an experimental lab to say, here are some use cases that aren't yet being met by the core specs. Can we extend, can we expand, can we fill those gaps? So one of these is trying to solve the problem for patient-facing apps of how do I select the right provider to connect to? And so, for example, this is an open source patient-facing app that Dan Gottlieb built as part of a research project at the Harvard Department of Biomedical Informatics. It's called Procure. It helps patients gather their own data, and it has this, I would say, moderately okay menu to find a healthcare organization to connect to. And if you know exactly the name of your organization, you can find it in this list and you can hit connect. But like maybe your health system is called like Mercy, and there's like a lot of health systems called Mercy, and you're not really sure which one you're supposed to pick in this list. And maybe you can find your state here, but this one doesn't have a state. I don't know. Honestly, I have no idea if this is my health system or not. So that's a problem that we want to be able to solve. And there's a pretty strong motivation to solve it. So some apps today are solving this by building relationships one by one with every hospital in the country and getting that hospital to fill out custom information. So like the Common Health app on Android or the Apple Health app on iOS, they'll go provider by provider and collect this information. They'll get somebody from each provider organization to share a logo and a description and the name of the organization, but it's an incredible amount of repeated work. And it's an opportunity for things to get out of sync or for things to get lost in the mix. And as part of EHR certification, today ONC requires, or for current certification, requires every EHR to publish a list of endpoints. But they don't say a lot about the metadata around those endpoints. So basically, you could just have an array of FHIR URLs and be done. But if you're an app developer, that doesn't quite solve the problem. Like, yes, I know the endpoints, but how do I help my patient actually find the right one for them? So this is what we call the patient access brands. The idea being, how do we surface the right kind of branding information that patients can actually use to make an informed choice? And I won't go through the details of it, but maybe I'll show you a quick example. We try to tackle some of the interesting organizational structures that exist in the real world. Like my healthcare provider in Madison, Wisconsin uses an EHR that's actually maintained by an organization 2 states away because they're kind of part of a network. They're affiliated with that provider, but their name is totally different. So me as a patient, I don't know that my healthcare provider is part of something called Unity Point, but the portal that I need to go to is called Unity Point because that's the organization that provides the portal. So, one of the things that we offer in this branding project is a way to describe those relationships. So maybe this Unity Point organization publishes their portal details, and then various affiliated healthcare providers who leverage their portal infrastructure can have their own brands published, each with a name and a logo, and each associated with this central organization that's actually providing the infrastructure. So we have a FHIR data model for this kind of thing, where you can say not just where are your FHIR endpoints, but you can also have an array of the organizations and the relationships between those organizations. And they're decorated with things like the logo for each brand, the URL of the main organization hosting it, the URL of the patient portal itself, description of what kind of data is available in the patient portal, what states or locations are serviced by that provider organization. The idea is to put enough metadata into this standardized package that consumer-facing apps can have everything they need to provide a good user experience. It's been a fun project. We thought we could scope this out as just a few months worth of work in the Argonaut project this year. And we've more or less stuck to that schedule. We held a connect-a-thon on it last week, a half day, where we got a couple of EHR vendors implementing support for these APIs. I think the main question at this point is, how many of these fields are really going to be optional in real life? We can have a rich and wonderful data model, but if nobody ever fills it out, it's not really going to be providing that much value. So I think that's the big open question for me is can we get to a point where EHRs are publishing the data that actually fill out this model? And then the last project that I want to highlight in terms of new work is one that's going on in Argonaut this year that we call the Smart App State Project. And the idea here is that some kinds of applications manage some data on their own, maybe something as simple as configuration data. Like when a user launches this app, maybe they've got a preferred color scheme or a preferred layout of tiles on the screen that they like to have. Where does that user configuration data live? As an app developer, you can stand up your own data store and keep stuff there, which is perfectly fine. But now you're in the business of maintaining that stuff. And sometimes you actually don't want to maintain that stuff online. So another example would be an app like what Apple has built with health records, where they have a way for individual consumers to share their health records with their doctors or with their clinicians. And the way this works is that Apple has an EHR embedded app that can display at-home data like a patient's activity and heart and ECG readings. And this embeds in the provider's EHR. But Apple doesn't want to have access to this data. They don't want to store it in a form that they can see it. And so they want to be able to put just a little bit of information, like an encryption key, into the EHR rather than storing it on their own servers. And that provides for end-to-end encryption. So there's a lot of use cases where an app could benefit by being able to write just a tiny bit of data to the EHR. And the EHR doesn't need to understand the data. The EHR doesn't need to surface it in workflows. It just needs to keep it and make it available to basically that app or maybe a small related set of apps that can work with that piece of configuration data. And so that's the goal of the Smart App State project. We started off, I naively said, well, FHIR has this basic resource, so let's use basic. And apps should be able to maybe post a new basic resource to the EHR, and it'll have a code that says what type of basic it is. And then later the app can query for that stuff. And it seemed to meet a lot of the functional requirements. But then we got some feedback from the EHRs that said, well, we're going to be managing all kinds of stuff in BASIC. The requirements here are actually much narrower. We maybe want to be able to route these requests to a separate microservice that's going to focus just on this kind of API call. We went back and forth a little bit. We landed on an API design that was really focused towards this specific Smart App State capability. And we basically defined an operation that allows the app to modify state, which is to say create, update, or delete. And the state is pretty limited, but it's a basic resource that can point to a subject, which is what patient's record are we attaching this to, or what user's account are we attaching this to? And there's a code saying what kind of state is it? And then there's extensions. And what we say is these need to be small. Like these can't be like arbitrarily large data sets. And so we're picking an upper bound that EHRs would need to support. Something like maybe 256 kilobytes is sort of the current drafty number. But an app can put whatever 256K it wants into a string inside of that extension. And the idea is if the EHR supports this API, it'll hang on to it. And later, if the app comes by and it writes a query that says, get me all the state associated with this subject, it'll get back the basic resources that it wrote previously. So it's a very small API, but it's designed to unlock these use cases where apps can't or won't be able to manage their own state. And I should emphasize, this is not intended to be used. We actually prohibit its use for things where FHIR already has a good data model for the data. So an app would never use this to store a new problem that should belong on a patient's problem list. It shouldn't be using this to store clinical information that the EHR knows how to manage. It's just for stuff that is app-specific configuration or app-specific storage that the EHR really can't or won't interpret. So that's the Smart App State API. Depending on how testing goes, we're going to do a Connect-a-thon next month on this topic. We've got a couple of apps and a couple of EHRs who are signed up to participate. This is something that I think might be a good candidate for an addition to the next version of the Smart App Launch spec. So that's what I wanted to cover in terms of the grab bag of features. I see one question from Dave in the front, and then I think we can open to online questions as well.
One question from Dave in the front is, I see that in the basic structure, you've got person as one of the options, which is supposedly prohibited in the FHIR spec.
So if it's prohibited, then we don't do it. That's just a typo. But I do want to call out the subjects that we associate these with ought to be based on and ought to be aligned with the FHIR user claims that we support in Smart App Launch. The idea is if somebody could be launching an app, we want to be able to associate state with them. And so just in terms of the current language we have here, we say FHIR user can point to any one of these. But I think you're right that basic is not allowed to point to a person as a subject. Yeah. Let's just review for the source of truth, just to make sure we're on the same page.
Well, nothing except patients and related person can point.
Take it back. If this is allowed, we'll have a discussion offline. But I think we're actually okay. Are there questions from folks in Whova or other questions from folks in the room? Other questions in the room? Sure. Yep.
Hey, Josh. Thanks for the presentation. For the Smart App state, how do we scale? Like if there are multiple apps, so that many basic resources, or?
Yeah, for Smart App State, how does this scale? Yeah. So the expectation is that any particular app might or might not be able to write state to the EHR. If it is able to write state to the EHR, it's going to have pre-registered exactly what types of state it's allowed to write. So if I'm building an app that needs to store user preferences, let's say my app's URL is app.example.org, I might be able to register with the EHR and say, I want to be able to store state with this code, the app.example.org pipe user preferences. That'll be the code that I'm going to associate with my state. I'll be able to read such Smart App State. Other apps will not be able to read such Smart App State. So as an EHR, you can partition these smart state objects by app. You can enforce the security model to make sure that apps are only able to read and write the kinds of state that they've registered to read and write. And you can scale this independently. So it's designed to be implementable on top of something like a distributed key value store. Of course, as an EHR, you can implement this however you want, but our reference implementation, for example, and there's a link to this at the top of GitHub, this uses something under the hood, which is a service from Cloudflare called their key value store, not suggesting that particular storage as a HIPAA data storage solution. Your mileage may vary. You can find a thing that works for you, but we wanted to make sure that the API could be implementable with very few underlying requirements from the storage layer. So we think this should scale reasonably well. Other questions on this or any of the other grab bag of topics that I introduced?
So you mentioned that the 1.0 version of the standard is what's required by regulation today. What would be your expectation for adoption of this in the major EHRs and what's going to drive them forward and when?
Yeah, so the way that our current EHR certification program works in the US, the Office of the National Coordinator names a certain version in regulations, and that includes the SMART 1.0. And they have something called the SVAP, the Standards Version Advancement Project. So each year they can add to the set of what vendors are allowed to implement. And that's still optional. And then maybe at some point in the future, they'll add V2. And then maybe at some point farther in the future, they'll say, actually now V2 is required and V1 is deprecated. So that's kind of the formal advancement process. But I will also say we've designed this specification to allow for incremental adoption. And what I mean by that is if you are a certified EHR today, you're certified to Smart V1, your server works, it meets all the obligations, it passes the tests. Cool. You can still be a Smart V1 server and also include in your capability set any of these new features as well. So you can say, well, I do all that, but I also support V2 style permissions. I do all that, but I also support PKCE with a code challenge method. You can do all that, but I also support token introspections. And so you can layer on these features optionally as an EHR without even having to wait for ONC to introduce this into the SVAP because they're purely additive features. And I say that with a slight asterisk because this hasn't happened yet in real life. And sometimes when people dig into the details in real life, they realize that the story is more complicated. So maybe we'll realize that here too, but that's at least the plan. Other questions or comments from the room?
Hey, Josh. Question about token introspection. So if the EHR is supposed to put the FHIR user claim onto the response, does that mean the EHR is responsible for keeping a state of associated access token and ID tokens? So when an ID token is sent, it knows which access token to get the FHIR user claim from, or which ID token to get that claim from?
Essentially, yes. Although if you read the spec carefully, you'll see that we've got plenty of weasel language here. So one thing we have is a should. The other thing we have, which is to say, a token introspection endpoint should be able to tell you the FHIR user who is signed in for the authorization. And then the other bit of conditional here is at the top, we have this language that says when the specified conditions are met. And so here, like this would only ever apply if there was an ID token in the original access response. There's a lot of apps that don't do single sign-on. They don't need to know who the user is. And for those, there clearly wouldn't be a FHIR user.
Why not just add FHIR user into the access token?
Why not add FHIR user to the access token? So in general, the FHIR user is an application-facing claim that deals with a security property. Apps use this to make determinations about what data they want to show. So a common pattern would be, let's say I've got an app from a prescription drug monitoring program at the state level, and I want to do single sign-on. So my user is going to use their EHR account to sign into my app. And then based on who that user is, like I'm going to check and see if they're a state licensed user. And only if they are, will I share with them the data from my prescription drug monitoring database. So apps need to use these as authentication claims. It's not just a bit of context or a bit of metadata. It's a security property about who the user is. Think about this as an authentication technique. And so the short answer is for that app-facing decision, exposing that single sign-on information, the OIDC spec, OpenID Connect, exists for a good reason. There's a lot of ways to shoot yourself in the foot if you're not careful. One of the things that we do in OpenID Connect is we sign that whole identity token, so apps can move it back and forth between different components. And there's many other aspects to the OpenID core spec that give us better security properties. So we don't want apps to confuse a security critical sign-in with just one more piece of metadata about the context of the app launch. I say that like it's a super bright line. I recognize in real life it's not, but we didn't want to reinvent something that already works well in a standardized protocol. That's why we lean on the ID token in the app-facing API. For the token introspection use case, the analysis is a little bit different because the server that's calling token introspection isn't relying on this information to do user authentication. Does that make sense? Okay. Yeah, please.
Josh, first, I think a thank you to your contribution to the FHIR community over the years. It's been really valuable. And really more of comments on the work you've done on scopes in V2. As an IG writer, I think we're starting to see instances where we've got the same basic resource being used for different purposes and the need to actually differentiate that. And so the ability to do those granular search parameters, I think, is a really valuable contribution.
Thank you. I should call out, like, I have a certain amount of anxiety about this as well. I already mentioned I don't think it meets all the use cases because it's very data focused and not necessarily like patient understanding focused. The other challenge, and we do call this out in the spec, we say, in theory, with arbitrary FHIR search parameters as parts of your scopes, you could do complicated things. You could use chaining, you could use modifiers, all kinds of stuff. And we say, we explicitly call that stuff out as experimental. We say we definitely don't expect this stuff to work out of the box. We think that servers are likely to have to directly configure support, not just for this stuff, but probably for every one of these fancy scopes. So we have a standardized scope language, but that doesn't mean you'll get out of the box infinite flexibility in real world systems. That's kind of the threading of the needle that we've tried to do.
Yeah, one of the initial examples we're seeing is like the explanation of benefit resource being used by Karen to express claims. But now we're also looking at that same resource to use prior authorization. So you can use a simple type parameter to say, differentiate between those two groups, which may be required under regulation to be made visible to different user communities.
Yeah, that's a great point. I think we will see more of these being called out in implementation guides at the point when these granular scopes are actually part of the regulated API service area. And so I think we're also going to have this period for a couple of years in the meantime where we say more and more, can we get by without it or do we need it? And we'll see how it goes.
Hey Josh, thanks for the presentation. So I saw with the smart app state, it looked like there may be some overlap with like the smart style URL and maybe the patient and encounter context. Can you speak to those and maybe help clarify for me like how those all fit together in the universe? Yeah.
You may have like a richer insight than I do, because at first blush, I don't actually see a connection, but let me say what I think each of those is, and we can dig in and see if there is more of a connection. So when you launch a smart app, the app can learn various kinds of context from the EHR. The app, and we call out some explicitly. So for example, we have a table of context parameters that we define in the spec that says if there's a patient in context, like I've got one patient's chart open, we can return that as an access token parameter. So the app knows which patient. If there's an encounter, same deal. We have some flexible ability to return other stuff as well. And then you mentioned one called smart style URL, which is kind of like, if your app is being launched in an EHR that's green, maybe you want your app to be green. So we'll point you to a JSON file that has a color scheme and fonts and stuff. And this came up a little bit in the introduction to Smart. Somebody asked about this, and I said, we talked about this a lot in the early days. There was a lot of interest in making sure that the apps wouldn't be too jarring. So we added this, but in real life, we called it kind of an experimental feature, and it hasn't been widely used. Like, turns out not to be, maybe not that useful, or maybe we're just not ready for it yet. Maybe it's the wrong solution. I'm not sure. And I'm hoping Isaac's actually going to make a counterpoint. So is it being used? Anybody using this? Raise your hand. I mean, is it available from EHRs? Because if it's not, then no one will raise their hand. Isaac says, yes, it's available from Epic. Anybody ever seen it? Anybody ever touched it? Anybody deeply feeling the lack of it? So yeah, I think this is a good example of, like, it's really hard to know in the standards community. Somebody raises this and says it's important and it sounds important, but like, is it? And the real test is you develop a solution for it. The solution never gets used in real life. Maybe that tells you it's not important. Maybe that tells you your solution was bad. Triaging that is its own subtlety, but we'll leave that as an exercise for later. Coming back to your question, so these are all different kinds of context the app can learn about at launch. But ultimately, the context is stuff the EHR knows that the EHR needs to know. So it's being passed from the app says, hey, do you have anything to tell me? And the EHR says, I sure do. It's green today, and the patient is patient 123. Smart app state is different. App state is something that the app asserts on its own and just needs to keep track of later. So next time this app is run, it wants to remember that the user is red, green, color deficient. It's not something that the EHR knows and is telling the app. It's something the app learned for itself and doesn't want to forget. So maybe that's the way to think about it. Awesome. Other questions, either from online or from the room?
We're just about out of time, Joyce. So perfect.
1 minute? No, who the question?
Okay,
I can answer a question in 1 minute. I'll talk even faster.
For servers supporting tokens from multiple IDPs, is there any standard built around request to the server identifying the issuer of the token for when the token is opaque and the issuer cannot be derived directly from said token? In other words, how can the server know what IDP an opaque token is from?
Great question. The short answer is no. In our current infrastructure, when a server gets one of these access tokens, the server is supposed to know who to check with. So if I'm building an imaging server, the common scenario today is I'm going to do token introspection on the EHR's authorization server. And the question that you read is like, well, what if there's 5 possible EHRs here? I don't have an answer to it, but that might be an interesting direction for future work. It's sort of a crawl, walk, run story. Awesome. Thank you.
Okay, thank you, Josh. So now we're
right.
actually out of time. Thank you so much.
Thanks all.